Hello viewers, welcome back to my channel. I hope you're enjoying all the problems that I am uploading. If you haven't subscribed to my channel yet, please go ahead and subscribe. Today's problem is shift 2D grid. Given a 2D grid of size m by n and an integer k, you need to shift the grid k times. In one shift operation, element at grid ij moves to grid ij plus 1. Element at grid I n minus 1 moves to grid I plus 1 0. Element at grid m minus 1 n minus 1 moves to grid 0 0, right? So basically, if you are given an operation, right, for each shift, right, shifting the 2D grid. So if you imagine like shifting the array, right, let's go ahead and take the example of single dimensional array, right? So 1 2 3 4 5. So let's say if we are shifting by 1, so what that becomes actually, so it will become as, so there will be an empty space, we'll fill that empty space and we'll come back 1 2 3 4, right? So that's what it is, and the 5 shifted comes here, right? So that's what is the shifting by 1 in the single dimensional array. But here we are given a 2D grid, 2D array essentially, right? So let's say what we are saying is if 1 2, right, 3 4, right? So if this is the one, right? So if we shift by 1, let's say what it will become, right? So we are saying as we left first character empty, right, in the single dimensional array, so let's keep it is empty, right? And the second character will be 1 because we shifted, right? And so where should 2 go? 2, since the length of the array is 2 by 2, right, it cannot go further to the 0 3 location, so it has to go into the second line. So it will start 2, right, and 3 will move to the next. So now for 4, if we move, where should it move? It should go back to the first location, right? So this is what the explanation given here. In one shift operation, this is how it is going to move. So ij moves to I plus 1, sorry, ij plus 1. So same row but next column. But what if next column is not there, right? So just exactly this situation, I n minus 1. So that is the last column. So what will happen to the last column's element? It will move to the next row, right? So if you see the index, right, here it is I n minus 1, it will move to I plus 1 0. That's how the move. So 2 is the last element, right? So where this should move? Into the next line first location. That's what we moved. So that is what is the explanation here. So what is the where does the last element go? To the 0 0. This is the last element, right? It will move to 0 0. So 4 should move to the 0 0. That's what we move. So this is what the shift by 1, right? But we are given with a shift by k. We don't know what is k, right? So we are given with k shifts, right? So we need to shift this grid by k times. So obviously the brute force way is we keep on shifting k times, right? So you would need to go through these shifts by k times, but that is not feasible. What if k is like 20,000 times, right? So if you were to shift this 2 by 2 matrix, right, 2 by 2 matrix by 20,000 times, right? So are you going to really shift that grid, the 4 elements, by 20,000 times? Not really, right? So there should be an efficient solution than shifting by k times, right? So that is what we are going to actually look into, right? So just to give you the better understanding, we have a grid and we have to shift the grid elements by k times by following these rules, right? So if we have m by n grid, right, if we have m by n grid, right? So how many elements it will have, right? M into n, that's it. So if you have 3 by 3 grid, there are 9 elements. If you have 2 by 2 grid, there are 4 elements, right? If you have n by n grid, m by n, m into n elements, right? So that many elements are there. So if you do one shift, right, it will become this, right? I am taking the example 1, 2, 3, 4 and shift by 1, it became 4, 1, 2, 3. What if we shift one more, shift by 1 again, right? So what this will become, right? So it will become 3, 4, 1, 2, right? So again, if we shift by one more, what will become 2, 3, 4, 1, right? So shift by one more. So what will become, right? So after how many shifts it became the original one? So if you have to shift 4 times, right, it became original one. It's coincidentally 4. So we are shifting 1, 2, 3, 4 times, right? Coincidentally, this is if we shift m by n times, right, that is equal to the same original matrix. So let's say if you are given with this array and k is equal to 4. So do you have to do any shifts when k is equal to? No shifts required actually, right? No shifts required if k is equal to 4, right? Because before shifting and after shifting, k is actually the array is actually same. So if k is equal to m by n, do you have to shift? Not really, right? So that is one thing that we have to observe. So k can be anything. So if I say k is equal to 20, let's say k is equal to 20, do I have to do any shifts? That is a good question to solve. So let's try to understand that first. So if k is equal to 20, do you have to shift? So the answer is you don't have to shift anything. So you can return the array as is, right? So you can return the array as is, right? But since we can't do a specific number based solution, we are going to propose a generalized solution for this, right? So what we are going to do is we are going to take a mod of k mod, right, k mod m by n, so m into n. So this many shifts are required, this many shifts are required for us, right? So this is the generalized algorithm. Just like we saw, for every 4 shifts, right, the array is back to its original form. So from that, what we could say is we need k mod m by m into n shifts. So for 20 k's, right, let's go ahead and look at 4 k's, right, 4, right, 4 k is 4 mod 2 into 2, right? So that is 4 mod 4, right, which is 0. So that means we don't actually need any shifts, right? So let's look at the k is equal to 20 example. 20 mod, right, and 2 into 2, 2 into 2. So what does that mean? 4 mod 20, sorry, 20 mod 4, right, 20 mod 4, which is happen to be 0 again, right? So we need 0 shifts even when k is equal to 20. So but what is k is equal to 21? Let's say k is equal to 21, right? So 21 mod 4. So that means we need just one shift, right? 21 mod 4 is 1. That means we just need only one shift. We don't actually need 20 shifts. So by looking at that, right, if you say 20,000, if k is equal to 20,000, right, that what does that mean? 20,000 mod 4, which is equal to 0, right? So we don't actually need to shift. So we were thinking, okay, do 20,000 shifts and get away with it, right? But actually you don't need to do any shifts at all, right? So finally the number of shifts we are going to calculate with k mod m by n. So that many number of shifts that we need. But do we actually need that many shifts is another question. So what is m is equal to 100 and n is equal to 100, let's say, for example, right? So that means you have 10,000 elements, right? So let's say if you were asked to do 9,999 shifts, right? So it's k is equal to that one, right? So you do have to do some shifts, right? That is equal to k is equal to 9999. But do you really want to do that many shifts? Not really, right? So we are going to devise the algorithm, right, for this purpose. So for this purpose, right, so the algorithm that we are going to follow is, let's say, right, let's say we have this grid with m by n. Until then we have done, so we are going to say m by n grid is there. So that means in grid there are m rows, right, and n columns. So that means each row you have n elements, right? Each row has n elements, right? Each row has n elements, isn't it? Each row has n elements, and like that there are m rows, which gives you m into n, right? So in a way, what you can say is, first row n elements, right, n elements, right, second row n elements, right, so on, right, so on, mth row also n elements, right? So this is how we have. That is a simple understanding, right? Each row has n elements. So if you look and try to observe, right? Look and try to observe. So first row, second row, every row has n elements. So this is the logic that we are going to utilize, right? This is one of the pointers that we are going to utilize in order to come up with the logic. So now that we know each row has n elements, so let's try to number them, right? Let's try to number them. So now, so 1, 2, 3, 4, 5, right? Let's say n is 5, right? So then the next thing is 6, 7, 8, 9, 10, right? 11, 12, 13, 14, 15, likewise, right? So since these are 2 digits, let me just do like that, so that it will be easy for people to understand, right? So that's the number goes on. So this is what I am going to use the logic for. So what I am essentially doing is converting the indices. So we call this as 0 0 in matrix, right? And we call this as 0 1, this is 0 2, this is 0 3, this is 0 4, right? This is 1 0, 1 1, 1 2, 1 3, 1 4, 2 0, 2 1, 2 2, 2 3, 2 4, likewise, right? So that is my convention. Basically you are given with the index of the cell, right? Index of the cell, the row and column, right? But what I'm trying to convert is convert it to a number and shift that number by k positions and convert it back to row index and column index. So you are given with ij, right? Ij, right? So from this what you can say is, when grid is m by n, ij means, so that is ith row and jth column, right? Ith row and jth column, right? So in that case what we are going to do is I minus 1 into each row has n elements, so n plus j. So this is the value that I am going to assign, right? So this is the what is a serial index, right? That's what serial number that we are going to. So this is the serial number that we are going to have. and to this serial index I am going to call it as SI, right? SI, right? So now I am going to do SI plus K because we need K shifts, right? We need K shifts. So you do K shifts. So K is what is obtained after doing the mod. Remember, so K is equal to K mod M by N. So whatever that we have obtained. So this is the one, right? So K is this K I am referring, not the original K. So I overrided K with K mod M by N. So this K. Now we are, what I am doing is SI plus K, right? So now we have to convert this SI plus K into some X, some Y format, right? Some X, Y format, right? So how are we going to convert? We know each row has n elements, right? So what we are going to do is SI plus K, right? SI plus K divide by n. That will give you the row index. That is nothing but X, right? Now we need to find out column, right? So now SI plus K, right? SI plus K, and you do the percent what? N. That will be the column, right? So that will be the column. So how many are left over? Or simply what you can do is SI plus K minus row in the X into N. That is also you can do. So this is one way. Other way is SI plus K minus X into N. So this will be our column, right? Right. So this is one more way to do it, right? So now you have XY index. So whatever the character that you have at IJ, put it at XY. That's it. We are done with it. So the same logic that we are going to see in the code now. Let's go ahead and try to understand the code. Right. So as I said, we are given with a grid and a K, right? So we are saying length, the m rows and n columns. So since we have to written in a list, just for the readability, I have created an answer two-dimensional array and then converting the two-dimensional array back to the I list of list. But you don't have to actually do this. So you just create a I list and modify this code accordingly. So that also works. You don't actually need answer and answer list both. So answer list is enough and you have to modify the code accordingly. So this is just for a better readability, I have declared answer array, the two-dimensional array. So what I am doing is creating the two-dimensional array which is equal to the grid, the m by n. So that's what I am doing here. And as I said, we are doing K mod m by n, right? So that's what we are doing to get the real K. And as we said, every ij we are going to get a xy, right? We are going to transform ij into xy, right? Ij into xy. The same logic whatever we described here is going to be used. So get updated coordinates. I am passing x and y as a reference parameters and they will have the values which are required. So once I have xy in the answer array, I am going to put the ij, grid of ij, the element in the ij I am putting in the xy, right? So once I have filled answer array, I am converting that to I list of list. So this conversion I am doing just because we need to give it as a list of list. So I want to repeat again, you don't actually have to declare answer array and convert it back. What you can do is you just directly declare answer array, modify a little bit of code here and get away with it, so that you don't have to declare two things, okay? And let's go ahead and try to look up what is the get updated coordinates. And finally here in this case we are just returning the answer list, that is simple. let's go ahead and try to understand what is there in get updated coordinates. It is the same logic that we are going to use, right? So it is passed with like 5 different things. One is the ij, like the original ij, where we are going to modify it, right? And mn, that is the number of rows and number of columns, and k is the number of shifts required. Okay, so multiply I with the number of elements in each row and then add j to get the cell number. This cell number is as if you are counting from 0. So in my previous example I started with 1, but since the arrays are 0 based index, I am doing it counting it as we are counting from 0. Basically it's a serial number. So now once you have that number, you add k to that. So you add k to that. Now try to get the row number. So row number is temporary of I, number percent n. And so this is another way. If the row number is more than the row number, that means you probably are calculating the this for the coordinates in the last row. So if you are calculating the coordinates for the last row, right? So at least one element have to go to the first row, right? So if the row number is more than the row number, then you are going to do the mod by the number of rows, right? So it has to go back to 0 and assign the temp to the row number, and column is also the similar number percent n, right? So that is simple. So basically this is what is the important method in the whole thing. So let's go ahead and try to look at the time complexity for this algorithm, right? So we are given with a 2-dimensional grid. So time complexity that we are going to create this thing is m by, this is m basically, right? M, and here we are going through m by n times, right? So there are 2 for loops, m by n. So for each time we are doing some specific calculations here, right? So this is constant for all the m by n times. So the overall time complexity for this will be order of m by n. So even if you don't put into answer and directly take the answer list of list, right? It will not change. The essential time complexity for this algorithm is order of m by n. So let's go ahead and write that down. So time is equal to order of m by n. So where m is the length of the m is the number of rows in the grid, n is the number of columns in the grid, right? So that's what it is. And time, space, right? Space. So as I said, I am using 2 placeholders, but 2 are not necessary. So by considering only 1 placeholder is required to return the answer, what I am going to say is the placeholder required is also equal to the length of the grid, right? The number of rows in the grid and number of columns in the grid. So that is order of m by n again. So that will be also order of m by n. So time complexity is order of m by n and space complexity is also order of m by n for this particular algorithm. So if you have any questions, please post them in the comment section. I will get back to you as soon as I can. If you haven't subscribed to my channel yet, please go ahead and subscribe and also share among your friends. If you want to get future updates on my future videos, right, please go ahead and click the bell icon. That way you will be notified with all my future videos. Thank you for watching again. I will be back with another problem from Leetcode very soon. Till then, goodbye.